Good morning, class. Here's practice test number 5, module 5, covering chapters 10 and 11, chapter 10, analytic geometry, chapter 11, sequences and series. And here's chapter 10, analytic geometry. Number 1, find an equation of the circle with its center at 1, -2 and radius 2. Graph the circle. Definition. Circle. A circle is the set of points in a plane that are the same distance called the radius from a fixed point called the center. Therefore, if it's centered at 0, 0, x squared plus y squared equals r squared with the radius r. If it's centered at h and k, x minus h quantity squared plus y minus k quantity squared equals r squared. That would be the standard form. So that's the synopsis of that. Of course, the area is pi r squared, the circumference is 2 pi r. In this case, we know the radius is 2. The center is located at 1 minus 2. So therefore, according to this formula, x minus 1 quantity squared plus y minus minus 2, which makes it plus 2 quantity squared, r is 2 squared, which makes it 4. So here's the center. Now you go r units, which is 2 units, up and down, left and right. So left and right. One, add 2, 1, subtract 2. Now -2, add 2, subtract 2. And that's it. So very straightforward, everybody. We're going to move on. Write the equation of a circle in standard form. Identify the center and the radius. Graph the circle x squared plus y squared minus 4x plus 10y minus 7 equal to 0. And to do so, we are going to put that in standard form, which means we are going to put the x squared and minus 4x next to each other, y squared and 10y next to each other, move the -7, complete this square. So to do so, in this case, this is b. Divided by 2 is -2. Squared is +4. We're going to add 4 to both sides. This one, b, is 10. Divided by 2 is 5. Square root 25. We're going to add 25 to both sides. So this is, and the way it works, class, it's always the variable, which is x in this case, and b over 2, which is -2 here, is x minus 2 squared. This is y plus 5 squared. Add them up, we get 36. So that's very straightforward. We have the radius, we have the center. So the center is located at 2 to the right, 5 down. This is -5, this is positive. So 2 to the right, 5 down. And now all we have to do, look at the radius and say we are going to go to the center and go R units, 6 units to the right and left. So to the right and left, that means if we add, we get 8 here. If we subtract, we get -4 here. Up and down, if we add, we get +1. If you subtract, you get -11. So those are the two pairs. And the second two pairs, those are the graphs. Now, we use those 4 pairs to help us graph, okay, everybody? Graph the ellipse by finding its center and vertices, x² over 25 plus y² over 16 equals 1. Here's the graph of an ellipse. Because it's elongated along the x-axis, that's the major axis. A0 and -A0 are considered the vertices. 0 minus b, 0b, those are the points that are considered co-vertices, if you will. So here's the F1 and F2, focus 1, focus 2, the foci. So an ellipse is a set of points in a plane. The sum of whose distances from two fixed points is a constant. The two fixed points are called the foci. Each is a focus of the ellipse. F1 and F2 represent the two foci of an ellipse. P F1 plus P F2 is fixed and is 2 times the value of A. So from here to here is A, from here to here is B, from here to here is C. So x² over a² plus y² over b² equals 1. If it's centered at 0, 0. If it's at h and k, x minus h quantity squared over a² plus y minus k quantity squared over b² equals 1. The area for the circle is pi r², which makes it pi ab here. Remember, circle is a special case of an ellipse where a and b are equal. We call it r. And b² plus c² equals a². As far as this formula is concerned, sometimes A is larger than B, which means it's elongated along the X. We use this formula. Sometimes B is larger than A, which means elongated along the Y-axis, in which case we put the A² here, B² here. I like to keep the A² always under X², B² under Y². And so clearly this is centered at 0, 0, with A being 5, B being 4. So the center, and then the vertices are 5, 0, minus 5, 0, because it's elongated along the x-axis because A is larger. And then from the center B, that means 4 units up and down, 0, 4, and 0, -4, and put them together. This is close to a circle. It's not a circle because A and B are not the same. But the closer the two values, the closer the shape to a circle. Identify the coordinates of the center, the vertices, the co-vertices, and foci, graph the ellipse, and this is the general. First and foremost, you notice it's centered at -5 and 7. A is a 2, B is 3, A is square root of 4, B is square root of 9. Okay, so we are using this formula. So you come up with the center. Center means go 5 to the left, 7 up. This is a portion of a rectangular coordinate system. In fact, it's really mainly the second quadrant for the sake of being able to show the graph. So we go, this is -4, okay, negative. We go 5 to the left, we go 7 up, this is 8, this is 6, so in between. So roughly here. Now, A is 2 to the right and left, B is 3, up and down. But understand what happens. The vertices, because B is larger, then it's along the y-axis. It's parallel to the y-axis. So we are going to go B units up and down to find the vertices. So Here's the center. We're going to go up by b. 3 and 7 becomes 10, so minus 5, 10. We're going to go down. 7 minus 3 is 4, minus 5, 4. Up, down, and there you have. So vertices are located at minus 5, 4, and minus 5, 10. So it should be very straightforward, everybody. Going back to the center, we are going to go A units left and right. A is 2. So we want to go 2 units to the left, minus 5 becomes minus 3. And we go to the left becomes minus 7. My apologies. You subtract, you go to the left. And you add, you go to the right, becomes negative 3, 7. So minus 7, 7, negative 3, 7. So go to the left and right by A units. Now, of course, that's the graph, by the way. Okay. Now, we either use a squared plus c squared equals b squared, or b squared plus c squared equals a squared. Depends which one is larger. As you can see, b is larger. So clearly, we're going to use this one. 4, 9, we already have it. So c squared becomes 5, and c becomes square root of 5. Foci is always along the major axis. Okay, so it's here. So it's the same coordinate as the center, goes up by square root of 5, goes down by square root of 5. So center, we are going to add and subtract from 7 this number. Almost 2.8, 2.2, and we get almost 4.8. Same thing here. Those are the foci. This is the graph. So that's pretty straightforward. We're going to move on. Use the graph of the ellipse to determine its equation in standard form. Obviously, we are going to use that, and we are going to locate everything. The center, it's elongated parallel to the y-axis. The other point, so let's start with the center, located at negative 2, 2. The 2 vertices, because this is longer, located at negative 2, 5, negative 2, negative 1. Co-vertices, 0, 2, minus 4, 2. Elongated along the y-axis. So this is B, this is A. This distance A, or this distance A is a 2. This distance is B, or 3. So A is 2, B is 3. Now we are ready to plug in X. Minus minus 2, that means X plus 2. Quantity squared over A squared over 4, plus Y minus 2 quantity squared over B 3 squared over 9. So that's pretty straightforward, everybody. Give the equation of the asymptotes and graph the hyperbolas. Part A, x squared over 16 minus y squared over 25 equals 1. Part B, y squared over 25 minus x squared over 16 equals 1. So I want to look at both cases. To do that, here's the shape of a hyperbola. First, let's discuss the definition. A hyperbola is a set of points in a plane. The difference of whose distances from two fixed points called the foci is a constant, pf1. So you have this graph. Pick any point and connect it to the two foci. pf1 minus pf2 is 2a. If this distance is larger, you get 2a. If it's the other way around, becomes minus 2a. So in essence, it's plus minus. Okay. Now, x squared over a squared minus y squared over b squared equals 1. Okay, the vertices are also the x-intercepts. Y squared over b squared minus x squared over a squared equals 1. In this case, the vertices are the y-intercepts. Now, in some texts, they change and they put, when it happens, they put y squared over a squared. The reason I don't, if you keep a squared below x squared and b squared below y squared, always, the asymptotes will always have the same formula, plus minus b over a times x. And this formula, a squared plus b squared equals c squared, will never change. Okay? And c is always larger than both of them, a and b. So both cases, I want you to see what happens here. Both cases, the center is at 0, 0. And a is 4, the same thing here. B is 5, the same thing here. In both cases, the center is not changing. A and B is not changing the way I write it. In this case, because x squared has a positive coefficient 1 over 16, then it has x-intercepts as the vertices 4, 0, minus 4, 0. By the way, the asymptotes are identical. The asymptotes are identical for both of them, plus minus b over a, 5, that means plus minus 5 over 4x. So these two are universal and they are not changing. The only difference between the two is would be the location of the vertices. So we have the same center, we have the same A, we have the same B, we have the same asymptotes. So these are the two asymptotes. This one has vertices at 4, 0, minus 4, 0. And those are the graph. This one has vertices because the coefficient of y squared is 1 over 25 in positive, has vertices at 5, but 0, 5, and 0, negative 5. Those are the asymptotes. 0, 5, 0, negative 5. That's the graph. That's the way it looks like. Okay, very straightforward. Identify the coordinates of the center, the vertices, foci, and the equation of the asymptotes. Graph the hyper. And we go with this formula. Obviously, it's centered at 1, 2. A squared of 9 is 3, B squared of 16, 4. So that's just right away. Asymptotes. Now, the way you write the asymptotes, remember y is plus minus b over a times x. Now y is replaced with y minus k. And x is replaced with x minus h. So y minus k equals plus minus b over a x minus h. So y minus k, that means y minus 2 plus minus b over a means 4/3. X minus h means x minus 1. So in other words, we have x squared over a squared minus y squared over b squared. So just write whatever you have. Instead of x squared, you have x minus 1. Okay, so that's the idea. You can keep this. You can take the negative 2 to the other side, make it positive 2. And this becomes plus minus 4/3 x minus plus 4/3 plus 2. And so actually, it's easier if I do it this way. So one of them is positive 4/3 x minus 4/3 plus 2. One of them is minus 4/3 x plus 4/3 plus 2. If you add these two, this is 6/3, with this one becomes 2/3. So 0 2/3 is obviously the y-intercept, and if you plug in, you clearly see minus 1/2, 0 is the other one. Those are the intercepts, everybody. Easy to find the intercepts. In this case, obviously 0 10/3. And if you set this equal to 0, you get 10 over 4 or 5/2, 0. So those are the asymptotes. Now I'm going to clean up my mess. And so you can easily graph those two points. It's important to do the asymptotes first when the center is not at 0, 0. So one more time. You want to graph a hyperbola, which is not centered at 0, 0. First graph its asymptotes. And here's the center. 1, 2. Now, because x minus 1 squared has a coefficient 1 over 9 in essence, which is positive, then the vertices are along this line, which is parallel to the x-axis. A is 3, so we go A equals 3 units to the right and the left of the center. So this is 1, 2. Go 3 units to the right, makes it 4, 2. Or 3 units to the left, make it 1 minus 3 or negative 2, 2. As far as, and the graph is pretty much done, but we want to find the foci, and therefore we need to calculate the a squared plus b squared equals c squared. And this is 9, this is 16, c squared is 25, c becomes 5. And therefore, this is the center. Go back to the center. Now c units to the right, c units to the left. So 5 units to the right and left, minus 4, 2, and 6, 2. the graph, the asymptotes, everything is working. All right. Use the graph of the hyperbola to determine its equation in standard form. Clearly, the center is at minus 1, 0. Um, and we want to find A and B. It opens up and down. The vertices are located here and here, B units up and down. So vertices minus 1, minus 1, 3, minus 1, negative 3, located B units up and down from the center. So that's the center again. And so this distance represents the B, or this distance from 0 to 3, B equals 3. Foci are C units up and down. So here's the two foci. So from the center, go up by how many units? If the y is 0 and the y for the foci is 3 squared of 2, and the foci are located at those two pairs, then C must be 3 squared of 2. So we have the B, we have the C, we can find A because A squared plus B squared equals C squared, plug in. As you know, this is 9, this is 2, the product is 18. And so subtract 9, and A becomes 3. And because it opens up and down, we use this one. The coefficient of x minus h squared is positive. We have vertices along the x-axis. If the coefficient of y minus k quantity squared is positive 1 over b squared, then it's up and down. So we use that formula. So next to y goes 0, so it's simply y squared. Next to x goes minus 1, x minus minus 1 makes it x plus 1. B, 3 squared, 9 goes down here. A, 3 squared, they happen to be the same, A and B. And so that's the answer. As far as the asymptotes, y minus k, which is y, equals plus minus b over a. B over a is 1, 3 over 3, x plus 1. And so simply this is 1, this is 0. So the asymptotes are plus minus x plus 1, which means One of them is simply x plus. The other one is minus x minus 1. So these are the two aspects. So that's pretty straightforward, everybody. A parabola is a set of points in the plane or curve such that every point on the curve is equidistant from a point called a focus and a straight line called a directrix. The distance from the focus to the P, any point P, and the distance from the P to the directrix is the same. So pick a point, call it P coordinates x comma y, and the distance from that point to the focus, and then drop a perpendicular. The distance to the line is called directrix. Directrix is a line that is perpendicular to the axis of symmetry. Those are the same. Over here, this is P, this distance is the same as this distance. So let me just write it here, P. So you pick a point, the distance to the focus is the same as distance to the vertex. Now, when you draw a line segment or chord parallel to the directrix, where it crosses the graph of a parabola, those are the endpoints of what we call lattice rectum. The focal distance, this is focal distance is P, and therefore this is P, and this distance is 2P. And so is this one 2P, therefore lattice rectum becomes 4 times P. Okay, these are the equations. Y equals x squared plus bx plus c, a times x minus h quantity squared plus k, or ay squared plus by plus c, a times y minus k squared minus k quantity squared plus h. These are the ones that we've seen it in previous algebraic courses. Now, basically, you solve for y squared or x squared, and it becomes the format that they are used here. And this part is called 4P. P and A. P is the focal distance. This is focal distance, everybody. From focus to the vertex. This is a focal distance. The relationship between that and A, if you write it in this format that we had, is that P is 1 over 4. Or A equals 1 over 4P. Lattice rectum was explained. The lattice rectum of a conic section is the chord line segment through focus parallel to the conic section directrix, and it has the size 4P. This distance is 4P. And so we also have this one, this distance. Okay. If I, let's say, pick points, the end points here or here, here or here. And to find the coordinates of those points, if it opens up or down, it has the same y coordinate as the focus, then plug it into the equation to find the 2 points, the x coordinates, or say from the focus, add 2p and subtract 2p, you get those points. Of course, if it opens sideways, you go 2p up or down, okay? If it opens up and down, you go 2p to the right hand. So these are various forms of routing. Identify the coordinates of the vertex, the focus, the length of the lattice rectum, and the equation of the axis of symmetry and the directrix, and so forth. the way it's given. By the way, you can always take it back to the format that we have in basic algebra that we have seen. Okay, you notice y has the coefficient, the exponent 2. So it's in essence like that. And it opens to the right or left accordingly. Just right away, you recognize that y squared means right or left. X squared means up or down. Okay. And so we can write it in this format and deal with this format, vertex format or the standard format, or just the way it's given according to that. Obviously, the vertex is located wherever x is. This is -4, wherever y is, which is 2, and it opens to the right, as I mentioned. Because y has the exponent 2, it opens to the right or left. This is positive, and therefore to the right. And because it opens sideways, obviously the axis of symmetry would have the equation y equals 2, because it opens sideways. So here's the center. Here's the axis of symmetry. Y equals 2. This is 2, 4, -2, 4, 2, and so like so. And if you go with that formula, this is, remember, if we are really looking at this one, the center that 0, 0, this is at center that h and k. So 4p is 4 over 5, which makes p 1 over 5 of 0.2. Now, what I want to add is this. Roughly, before even we continue, you should recognize, okay, the graph opens to the right, looks like that. The focus, and this is by no means to scale, is somewhere inside, and the directrix is like so. And this distance is the same as this distance, and it's the p. Therefore, if I want to find the location of a focus, I'll go back to the location of my vertex, and I go p units, which is 0.2 to the right. So -4 plus p is 0.2, makes it -3.8. And for the directrix, it is a vertical line, x equals some number. And what is the x coordinate of the vertex? -4. Go p to the left. That means subtract p 0.2 from that, and that gives you x equals -4 minus p, or minus 0.2. There you have it. I'm going to erase mine. So that's the focus, the directrix. That's the graph. Okay, so it's pretty straightforward. This is the lattice rectum, and it's 4 times p. Its size, if okay, length. They're asking for the length of a lattice rectum. Lattice rectum. The lattice rectum of a conic section is the chord through the focus parallel to the conic section directrix, 4 times p. Okay, or simply it's given here, this value, or 4 times 0.2, 0.8. So that's very straightforward. Now, what about the end points, those points if you want? There are two ways to do it. We know that they have the same x coordinate as the focus. Let's go back to the focus, negative 3.8. What is their y coordinate? Put it into the equation, replace the x with negative 3.8, and it gives you two y's. Those are the answers. That's fun. But is there an easier way? Yes. Here's the second method. Go back to the focus. X coordinate is negative 3.8. So the x coordinate for the endpoints is the same. What about the y coordinates? Add and subtract 2p. So go up by 2 times p. We said p is 0.2. That means go 0.4 up and go 0.4 down. So plus minus 2p plus minus 0.4. And so the y coordinate is 2, up 2.4, down 1.6. So those are the coordinates. That's faster and easier than this one normally. Okay, that's a faster way of finding. Use the graph to determine its equation in standard form. And notice, of course, it opens down. We have the axis of symmetry, we have the vertex, we have the focus, and you can use this format or this format. So if you go with the format of this course, x squared equals 4py, that means x minus h quantity squared is equals minus 4p times y minus k. The reason we say minus 4p, focal distance is always positive, okay? That's why they go with the negative. And the reason it's negative, remember, when it opens down, a is negative, right? That's why. So the vertex is located at negative 3.5. The focus is located at negative 319 over 64. So that's the vertex, that's the focus, and those are the coordinates. So the focal distance is the distance between these 2 points, which means their distance in their y coordinates. So 5 minus this number. So 5 times 64 is 320. Minus 319 is 1. So 1 over 64. So the focal distance is 1 over 64. And so pretty much we are done here because we have x minus h, that means x minus minus 3 or x plus 3. We have y minus k, we have y minus 5. And then now plug in minus 4 times p, 1 over 64, which makes it negative 1 over 16. And you're done. A second method class, we're going to use y equals a times x minus h quantity squared. We know it opens down. So this is the method we had seen previously, and we replace the h with negative 3, makes it x plus 3, and then k with 5. We've already discussed that the p equals 1 over 64. We came up with that. So this is there, this is there, and now use it. So ignore that. We go this route, and because the relationship between a and p is that we said a is 1 over 4p, okay, and we take it to be negative 1 over minus 4p in essence. And we end up with negative 16. And that's the equation. And I hope you recognize the two are identical. Given the function expressed in standard form, this is the standard form that was used in college algebra, intermediate algebra. F of x is a times x minus h quantity squared plus k, and find the x-intercept, the y-intercept, the vertex, find the axis of symmetry, all the good stuff. So f of x is that. We have two ways of doing that. One is to complete the square, and one is to write x equals minus b over 2. I explained both of them in a moment. So first and foremost, if you put these two together and take the 2 out, now we need to complete this square, and we notice, so this is one methodology. So we notice that b is 2, E over 2 is 1. Square it, you get 1. So if I add 1 here, in essence, I'm adding 2 times 1. So either I add 2 to the other side or I subtract 2 from the same side. It means the same. And it becomes 2 times x plus 1 quantity squared plus 4. Clearly, this gives us the vertex at negative 1, 4. So 1 to the left, 4 up, and it opens up because A is positive. A is 2 and it's positive. There it opens up, there is no x-intercept, or you can set this equal to 0. You notice that there is no x-intercept. You can look at b squared minus 4ac is negative 32 if you go back to this format, and that means there is no real solution. Y-intercept, it's again easier to go with this one, 0, 6. So if you have 0, 6, remember the axis of symmetry, we should recognize it as x equals minus 1. And so if this distance is given, for the same distance, we can find the other point. So this is the axis of symmetry, x equals negative 1. Because this is the axis of symmetry and this distance is 1 and 2, then the same distance 1 and 2 gives us the same y coordinate, minus 2, 6. And there you have the graph. So I hope you see that how easy it is to come up with the answer in this case. Now, what I want to add is this. Let me erase the work. If you don't want to complete this square and you just want to find the vertex, because they're asking you to put that in that format anyways, you have to go over the completing the square. But if you just want to find the vertex, remember x is minus b over 2a, which makes it minus b, which is 4, 2 times 2, which makes it negative 1. Now you plug in negative 1 and you find the y coordinates. When you have the vertex, then you can figure out the fact that a is 2 anyways. But completing the square is the method they're asking for this. Identify the graph, and we are talking about conic sections. What you should recognize that when we have x squared and y squared, it's either a circle, ellipse, or hyperbola. You bring them to the same side. Notice the same side, these two are identical. So same side. X squared and y squared. Identical gives you a circle. Same sign, positive. It's an ellipse. If you move that, you get 9x squared minus 16y squared. Doesn't matter about 144. They have different sign. It's a hyperbola. So circle. Okay. Ellipse and hyperbola. Ellipse and hyperbola. Okay. So those are very straightforward. Now, when we have one of them, by the way, this is like y. Either x or y has the exponent 2, but not both of them. They are all parabolas. Okay, because either x or y. So now, when x is squared, x squared means up or down. Y squared means right or left. So this one means down. This because a is -2 and we have x squared. This one is up because a equals 1 and we have x squared. This one is to the right because a is 1 and we have y squared. If we had -y squared, it would open to the left.